All right, today we're going to read the plate tectonics reading assignment and fill out some Google slides. So I'll try to remind you where to stop, or is a really good place to fill out information. So here we go. Tectonic plates. And you can follow along with me, or if you would like to, you can read on your screen and just listen to my voice. So here we go. Tectonic plates. We now know that scientists developed a new theory that combined continental drift theory and seafloor spreading. According to the theory of plate tectonics, Earth's crust, which is the top layer of the Earth, you learned this yesterday, the one we live on, is broken into sections. These plates can be thought of as rafts that float on and move over the rest of the Earth. When plates move, they can interact in several ways. They can move toward each other and what we call converge or collide. They can also pull apart or slide alongside each other. When the plates interact, the result of their movement is seen at the plate boundaries, which are the lines on the maps below. So if you take a look at this map right here, you can see the continents. Like here's North America, South America. This is North America is where the US is, right? And there's Africa, Europe, and Asia. But you see all these dark red lines, right? Or I'm sorry, black lines. Those are the plate boundaries. Take a look at the dark black lines above. Each section, our puzzle piece, is a plate. For example, the plate that includes the continent Africa is called the African plate. So if you take a look at it, they're often named after what they include. So look at the African plate includes Africa. The Australian plate includes Australia. But just like the video we saw yesterday, right? The movement of the convection currents underneath the Earth cause these cracks to form, right? So now would be a really good time to stop and go to your notes. So you're going to go to where your notes are, and you're going to fill out these. So the theory of plate tectonics, and you should be able to fill out all of these. Go back to the reading, see if you can fill in all of these blanks. So I would pause the video right now. Okay, let's read the next section of the video. And what we're going to do is we're going to fill out just the left part, this divergent boundary. So here we go. Divergent boundaries, plates moving away. The boundary between two plates that are moving apart is called the divergent boundary. The word divergent means to divide or separate. So if we listen to those words, divergent, divide, right? They're moving away from each other. So if you look at the picture above, you can see plates moving away. The arrows are moving away from each other. When you learned about seafloor spreading, that was a divergent boundary. Look at the picture above. Because of convection currents, magma, the name for lava underground, rises up and pushes the plates away from each other. So you can see it forming right there and pushing away. Lava comes out and quickly cools on the ocean floor, making new seafloor. This only happens, however, when the plates are on the ocean floor. That means that the dark line in the map to the right would have to be between two plates that are both in the ocean. So do you see how this black line connects two plates that are clearly in the ocean? And the red arrows show an example. What if a divergent boundary, however, happened between two land plates? See the blue arrow in the pic above. So if we take a look at this, we can see this line here that involves two land plates. See, now look at the picture to the left. When this divergent boundary happens, so it's still moving away, it is called a rift valley. Two land plates move away from each other. It looks like the land separates or stretches out, and a sunken depression forms. It will eventually fill with water. This is currently happening in Africa, and it's called Africa's Great Rift Valley. So you can see the boundary plates moving away from each other, and the depression, the sunken land forming, it forms a rift valley. And in Africa, here's what it looks like. So it kind of looks like there, something opened up and the earth moved away from itself a little bit, right, at the plate boundaries. So now would be a good time, since we just learned about divergent plates, to go back and answer these questions on divergent boundary. Okay, convection boundaries. Here we go. Convergent boundaries. Convergent boundaries, plates moving together. If new land is being added on the seafloor, how come Earth's surface doesn't keep expanding? That's because as new floor is being added with seafloor spreading, Other floor disappears under the seafloor. What? Yes, that's happening. This happens when plates move towards each other at convergent boundaries. So, kind of like when things merge, converge, they come together. There are actually three things that can happen at convergent plate boundaries based on if the boundaries running into one another are ocean or land boundary plates. So, here's an example with the picture. Look at the picture above on the left. If an ocean plate boundary moved towards another ocean plate boundary, the older, denser, which means heavier, ocean plate sinks under the newer, less heavy one. So let's take a look at this. Notice how the arrows are moving towards each other. So it's a convergent boundary, but that one bit of plate, right, moves underneath and slides under the other. This is a process called subduction. Think of like a subway with trains or a submarine. They both go underground, just like one of the plates in this subduction process. When the plates slide under the other, it causes a disturbance in the layer underneath called the mantle and causes magma to rise up and out of the crust. See how the magma or lava, which is the red part, bubbles up out of the ocean and forms volcanoes? So let's take a look at this picture. So one plate slides under another, but it disturbs that layer underneath and causes the magma to get pushed up and out, forming these volcanic islands. Pretty crazy, right? So it's kind of like when you get a splinter, right? The splinter would go under your skin and cause the part above it to get red and sore. This is how volcanic islands in the ocean are eventually formed. So two ocean plates running into each other. So now let's look at the picture above on the right, and I'll come back to it. This is also a convergent boundary, but in this example, an ocean plate boundary moves towards a land plate. So let's look at this picture. An ocean plate, arrows moving toward a land plate. This is clearly land right here. This is also a convergent boundary, but the ocean plate is heavier or denser, so it also goes under the land plate. The magma rises up, here's another bad analogy, like a bad zit, where the subduction occurs, and causes volcanoes to form on land. So let's take a look at that again. One of the plates, the ocean plate, is running into or moving under and sliding under the land plate. It disturbs the layer of magma underneath the crust, bubbles up, and causes volcanoes. But this time they're not in the water, they're on land, which makes sense because it's running into a piece of land plate, right? Okay, so now would be a very good time to stop and fill out some of this convergent boundary chart. All right, there is one more part though, it says, but wait, there's also a third way convergent plate boundaries can interact. Look at the picture to the right. If two plate boundaries move towards each other, they are both land plate boundaries. They don't subduct or go underneath each other the same way. Instead, they're both kind of lighter, so they collide and crumble up and push out and up together, forming mountains above the land. This is how many of our famous mountain ranges were made. So this is the third way. So notice the plates moving towards each other, the arrows, but instead of one going under the other, they crumple up and both pile on each other and make mountains. So go back to your sheet, and this is kind of the last little part. This is number 3 of convergent boundary. Okay, just a little bit more to go. Transform boundaries, plates slide past each other. Now we arrive at the last kind of way that plates can move, a transform boundary. This is when two plates, land or ocean, slide past each other, much like when you rub your hands together. They move in opposite directions or in the same direction at different speeds. So take a look at the picture below. Notice they're going up and down, right? Or kind of like if you were to rub your hands together. Either way, when one plate slips past another, earthquakes occur. So it causes the movement of the earth to shake and rumble. If it happens on the ocean floor, it can also cause an earthquake. One famous transform boundary is called the San Andreas Fault in California, which is the site of many earthquakes. And here's a picture of the San Andreas Fault. So this one's pretty easy. The transform boundary is the one that I always remember. So let's go back to plate tectonics, and you can fill in transform boundary. Now would also be a really good time to go to this chart and look at what's happening with the plate underneath. It's sliding under the other one. So it's a word that starts with an S. And you're going to do this bit of notes. Okay, let's read the last part and we'll be done. So let's review. When the Earth's plates move and interact, they can do three ways, right? They can either diverge from, and which means to move away from each other, divide, right? And so if you see this picture right here, the arrows are moving away. It's divergent. They're spreading away, just like seafloor spreading. Convergent plate boundaries move together. So you can see in this picture, the arrows are coming together. And this often leads to volcanoes or mountains. And then the last way we just learned about, transform boundaries when they slide past each other and cause earthquakes. And here's plate tectonics, right? In this case, these plates would be separating, right? And kind of like seafloor spreading, they're dividing. Okay. All right. The last thing you're going to do on your homework is you're going to go through these slides and look at the picture. Notice the arrows. Are they going towards each other, away from each other, or sliding past each other? And you're going to tell me what kind of boundary it is, what way the arrows are moving, and what is created. If you need to, use the picture, like here's a big clue of what's created, a mountain. Okay, and you're going to do that for the rest of the slides and then submit it and you're done. Use your reading, use the pictures and the arrows to help you. Okay, good luck.